In any radioactive substance, some of the atoms are always changing into different atoms. The time taken for the number of unchanged atoms to be halved is known as the half-life. In part A, we have substance A, which has a half-life of 25 days. How many days would it take for the number of unchanged atoms to be less than 10% of the original amount? Let's say that n is the number of unchanged atoms. That will be equal to an initial amount of unchanged atoms, which we'll call P, times 0.5 to the n, where n is the number of half-lives. Let's just think about how this works. If n is 0, 0.5 to the power 0 is 1. So at the beginning, n is equal to p, as it should be. After one half-life, there will be half the amount, p times 0.5, of unchanged atoms as there was at the start. So this formula works. Now, what we want is to have 0.1 p, so that's 10% of the original. That's equal to p times 0.5 to the n, and we can cancel a p, giving 0.1 is 0.5 to the n. Solving this equation will give us the number of half-lives. If we do a basic search, when n is 1, we get 0.5. If n is 2, 0.5 squared is 0.25. If n is 3, we have 0.125. If n is 4, we get 0.0625. So we have less than 10% when n equals 4. So 4 half-lives times a 25-day half-life gives us 100 days. But clearly, it's somewhere in between the two. We could search further, and there are other ways of getting an accurate answer, which we'll look at in the next example.